What we have here is a computer Adobe file of the Common Core standards for mathematics. I wanted to share these with you. A few things about them. One, you'll notice there are 93 pages. There's 93 pages of Common Core standards. We won't have to go over all of them because they're kindergarten through 8th grade, but they're available on the UEN website if you want to go to the UEN website. And you can look through them. Table of contents, there's an introduction we'll look at a little bit. And then you'll notice there are two sections here. One section is standards for mathematical practice. Another section is standards for mathematical content. Practice and content. Two separate things. And that's the first we've ever seen that in a core. The standard for content is the one everybody focuses on. But the standard for practice, to me, is more important than any content we can teach the kids. And I'll show you why in a few minutes. The two that I focus on are 7th grade and 8th grade. And I actually focus a little bit on some of the high school content. In fact, it's not the content you see here. I'll scroll down a little bit more so you can see that content. The high school content that I focus on is not divided up like this. In Utah, they decided instead of going with divisions of everything, algebra, geometry, statistics, and that type of thing, what they're going to do is go with grade levels, Math 1, Math 2, and Math 3. And so I focus a little bit on the 7th and 8th, and then a little bit on the Math 1 for high school content as well. You'll also see me focus on some of the grade 6 content as they come into 7th grade. Mathematics standard for mathematical practice. And if you want to pause this and read it, that would be great. There are 8 practice standards that these kids are supposed to learn and understand. The number 1 standard is make sense of problems and persevere in solving them. And the word make doesn't mean, in the term, when we say that doesn't make sense, it's interesting. When we ask somebody to make sense of something, we're asking them to create sense of the problem. But then when we express ourselves, that doesn't make sense, we're actually not even using proper English, because something that's inanimate can't be expected to make something. Make means to create. We are supposed to create sense of problems and persevere in solving them. And the problem itself can't create sense. You're the one that has to. And so the proper terminology isn't this doesn't make sense. It's I'm not making sense of this problem well. And perseverance is what will help in many ways to overcome that. I'll leave this here for a second and you can pause it and read that as well. The second standard is to reason abstractly and quantitatively. Being able to reason abstractly, take concrete ideas and then and put them into math formulas and numerical formulas and things like that, to put them in a context, mathematical context, and then to put them back into a real world context is an ability that we're trying to teach students as well. And we don't do that when we just say this is the set of steps we need to take to do it. The third step is to construct viable arguments and critique the reasoning of others. Being able to construct viable arguments is an extremely valuable piece of mathematics, and you'll notice that in many, many, many ways we don't cover that anywhere except for maybe in the geometry section when we're doing proofs. And to be able to critique reasoning of others means we have to understand what others are saying, so that means we have to know the language of mathematics. We have to understand what those words mean, and that's a pretty weak place in our curriculum at this point. We need to be able to model things with mathematics. Okay? This paragraph above here is part of constructing viable arguments. I'll leave that open for you for a minute. We need to be able to use appropriate tools strategically, whether they're calculators, whether it's your mind, whether it's math tools like formulas and things like that. We need to be able to use those tools strategically, not just ask the teacher which formula to use and then plug it in, but be able to know which tool to use when. Attending to precision means a student who attends to precision is simply that they in every step of the process, in every step of any problem that in any step of any problem that they're approaching, they're very precise in how they approach it, in how they speak, in how they communicate, in how they write things down, in what they write down. All of those things students understand are valuable in the process of doing and thinking through mathematical problems. Students are supposed to look for and make use of structure, and look for and express regularity in repeated reasoning. Mathematical structures are if we understand mathematical structures, it's much easier for us to use appropriate tools strategically and to model with mathematics. If we don't understand mathematical structures, we can do neither of those things. So we need to be able to look for and make use of structure, and look for and express regularity in repeated reasoning, which is another structure. A little more detail. Okay? Those are the 8 Common Core practices, standards for mathematical practice that students are supposed to learn. Something that's never been put in a core before. You'll find that also in the language arts core. One of the jobs we're supposed to do is connect those standards for practice to the standards for content. I would encourage you to come in, get into your computer, go to the UEN website, and look up the Common Core and actually start reading it, especially the practice standards. It will help you understand a lot more about what your student is doing in class.